Hey guys, happy Friday to you. Um, it's like bittersweet. This is that lesson that I give every year where it's the end of May. I've been teaching now for, I think it's 9 years. So I start to associate these lessons with the emotions that I get. And it's like this crazy emotion of pride on, working so hard in math. And this has been an extremely odd year for all of us in so many different ways. But the folks, a lot of people had like a way out, if you will. Like, okay, cool, I don't really have to work anymore. But there's been about a third of you guys that have held on, and I'm proud of you. So keep it up. So this is the final new concept lesson. Next week's going to look a little different, but let's go through it. Okay. So these are the three questions that I'm asking you. And I will explain how to find the answer for each one. I'll give you an example, and then you can go off and figure it out. So this is a hard week. We're working with the regular volume, which it usually takes me about a week to go over this concept until I get everyone from I'm terrible at math. Like once they woo, okay, I think I get it. I get it. Takes a while to get there. And then we only worked on that for a day, and then boom, we jumped right into classifying quadrilaterals, which again takes about a week for students to stop feeling horrible about themselves and start to get the confidence that they need. And then classifying triangles usually goes pretty well. So give yourself a break if you're frustrated, and good for you that you're still trying to figure this stuff out and you're still watching the videos. So let's go over these three things. Regular volume. I tried to sprinkle this in through the year on challenge questions and stuff because I knew how difficult it would be. But basically, this illustration over here gives us a good idea of what these irregular figures are. So here's your question for today. And if you look at it like these three different things here, so here it would only be two, obviously, but here the yellow's regular, the blue's regular, and the red's regular. Now, normally they're not color coded. You're just going to look at that one figure, and you're going to have to try to figure out the volume for that figure. And that freaks you out. That makes things difficult. But if you're in your brain, you're separating these figures into two totally different figures like they do over here. They turn it into three. Then it actually opens your mind up and it says, all right, this is not that bad. This volume is 2 by 2 by 6. This volume is 2 by 3 by 2. And this volume is 2 by 2 by 4. You find each of their volumes and you add them together. So over here, you can see there's a length, width, height. And then you find that, and then you have length, width, height. And then you just add those together to find the total volume. Now, here's our example that I'm going to complete for you to understand. Now, like I said, it'd be wonderful if it was color-coded, but it's not. But see, if you're someone that has the luxury of printing these out, you could turn it into two figures. And if you want to color-code it, hopefully your coloring is as good as mine is on the computer. Woo! Check that out. All right. Now, you didn't have to cut it there. You cut it sideways, which looking at it now, I wonder if it would have been easier. I should still have the numbers necessary. Let's see. Yep, I do. I have all the numbers that I need. So I need to figure out what this number is right here. I know that the whole thing is 6. Now, if I look right here, I know this is 4. So if this is 4 and the whole thing is 6, then 4 plus my piece that I need right here equals 6. So that has to be 2. Whew. So that's a 2, and this is a 2. So the base of this figure is 2 by 2, which is 4. And then the height of 4 is 4. Because if the area is 4, 4 goes up and down 4. So 4 times 4 is 16. So my whole entire volume of the red figure is 16. Now I'm going to go down. I'm going to change it to maybe a blue color. Now I have this figure left. And we have, do I know what this is right here? Yeah, it's the same as this, which is the same as this, which is the same as this. So this is 2. And then this is 4. So the area of the top is 2 by 4, which is 8. And 8 goes up and down with a height of 2. So this blue figure is 16 cubic meters. So now all I have to do, oh, check that out. They're the same. I just have to add those two bad boys together. What's 16 plus 16? 32. So the entire thing has a volume of 32 cubic meters. And hopefully you write better than I write with a mouse. And that's all you do for irregular figures. Irregular figures. All right. And then let's go to the next one. Classifying quadrilaterals. This is hard, man. This is difficult. And like I said, I think people get overwhelmed when they're like, oh my gosh, I'm supposed to memorize all those. Well, ideally, great. But they're usually going to tell you the definitions for them. So don't overthink that. And right now, you've never been taught this to the point where you should memorize it. So eventually, great. That'd be awesome if you memorize it, the properties. But right now, don't worry about it. So we have quadrilateral, parallelogram, rectangle, rhombus, square, and trapezoid. And the easiest way to think of this is a club. Well, if you hit all these characteristics, you can join our club. So your question today is, they give you this wonderful looking figure right here, and they say, circle all the clubs that it could join. And then you're just going to go through and remember what it takes to be in each club. And then if this figure demonstrates those qualities, circle it. So I will give you that same example with this down here. So quadrilateral, is it four-sided? Is it a four-sided polygon? Yeah, there's 4 sides and it's a 4-sided polygon. Parallelogram, that means there's, hi, I'm a line. Hi, I'm a line. We're parallel. Cool. That's 1 pair. Hi, I'm a line. Hi, I'm a line. We're parallel. Cool. That's 2 pairs. So in order to be a parallelogram, you have to have 2 pairs of parallel lines. So remember, parallel lines mean that they will never intersect if your imagination can extend them forever. Those 2 are parallel. So that's 1 pair of parallel lines. And then over here, up and down, is another pair of parallel lines. So does that have 2 pair of parallel lines? Yes, sirree, babarooski. Now, whenever I go to parallelogram, I like to cross off trapezoid, because trapezoid is the opposite. Well, not the opposite, but if you're a parallelogram, you cannot be a trapezoid. A trapezoid specifically says you can only have 1 pair of parallel lines. So that's definitely not a trapezoid. You cannot be a parallelogram and a trapezoid. What about a rectangle? Rectangle says, hey, we have 2 pairs of same length lines. So this guy over here is like, hey, you're the same length as me. That's 1 pair. And this guy up here looks down and says, hey, you're the same length as me. That's 2 pair. Are we a rectangle? Yep. Oh, and a rectangle has to have 4 right angles. Rhombus, they're all the same length. All the sides are the same length. So no, they're not all the same length. Same idea with the square. And remember, the only difference between a square and a rhombus is a square is a rhombus with all 90-degree angles. Not only, so it's a little more specific, like not only do you have to have the same sizes, but you also have to have 4 right angles, or you cannot join. And rhombus is like, nah, I don't care about your angles. If you have them, if you don't, just be all the same size. All right, that's it for classifying quadrilaterals. And then the last thing that we learned about was the classifying of the triangles. So this is the question in your Friday review up here on the top right. And then remember, when you're classifying a triangle, it has two names. The first name refers to its angles. Remember, no matter what, all the angles are going to add up to 180. And if they're all smaller than 90 degrees, then it's such a cute little triangle. If there's one right angle, then it's a right triangle. And if there's one that's larger than a right, then it's an obtuse. So the first name that we're going to give this one is acute. I'm just going to circle it because if I try to write that down, it's going to get nasty. And then which one would it be? Would it be an equilateral? Now that we're naming the sides, because all the sides are the same length, would it be isosceles, where two of them are the same length and one of them is not? Iso? Or is it that scalene looking like triangle over there? They're all different lengths. This one is an equilateral. So because all of them are equal length, so this is an acute equilateral triangle. All right. Try your best and then check your answers, and good job. That's it. That was it. We are finished on learning new material. So try your best, and then we'll see how you did.